In Windows, one of the first network troubleshooting tools you will use is ipconfig. It allows you to quickly verify IP information configured on network interfaces. I start by opening a command prompt. I can select Start and type cmd and then hit Enter. Typing ipconfig with no additional parameters shows me all of the network interfaces on my computer, along with IPv6 addresses, IPv4 addresses, subnet mask, and default gateway. Any interfaces that are unplugged show up as media disconnected. I'm going to go ahead and clear the screen. There is quite a bit more information that can be shown by typing ipconfig/all. This shows the same output as the previous command, but also gives the physical address or MAC address for each interface, whether DHCP is enabled or not, when the DHCP lease was obtained, and when it will expire. /all also lists the IP address of the DHCP and/or manually configured DNS servers. If DHCP is enabled on my network, there are additional control commands I can use with ipconfig. If there's an IP address assigned via DHCP to an interface, ipconfig/release will remove it. By default, if I enter the command without specifying a specific interface, it will release the DHCP leases assigned to all interfaces. I can use wildcards in the interface name to make it easier. These are simply asterisks. On this machine, I've got wireless LAN adapter Wi-Fi, so I'll type ipconfig/release *FI. Once the IPs have been released, I can query for new ones by issuing ipconfig/renew. In this case, I'm just going to hit the up arrow and change my command to renew. Again, I can choose to specify an interface or not. For you IPv6 lovers out there, ipconfig/release 6 and ipconfig renew 6 will control v6 DHCP IP addresses. There are also a few DNS commands that are great troubleshooting tools. I can flush the local DNS cache with ipconfig/flush DNS. Alternately, if I want to view the DNS cache, I can issue ipconfig/display DNS. Display DNS shows each entry, the type of record that it is, be it A record or CNAME, its TTL, and ultimately what it resolved to. An A record will be a direct DNS to IP mapping, where a CNAME is a DNS entry that points to another DNS entry for ultimate resolution. Linux isn't wholly different. To list the IP addresses present on the server, I simply type IP addr. To view the routing table information, like the default gateway, the iproute command can be entered. These simple commands are used daily in the world of network support and administration. When troubleshooting network connectivity, the next step after verifying IP information with ipconfig is to use the ping utility. If a client is having trouble getting out to the internet or just on the network, I'll first ping its default gateway. From the command line, I simply type ping and the IP address of the default gateway, 192.168.51.1. By default, it will issue 4 pings and uses 32 bytes per ping, reporting the latency of each ping measured in milliseconds. This is also known as the round trip time, since it measures how long it takes the packet to reach the destination and then return. When the 4 pings are complete, statistics like how many packets were sent and how many returned, as well as the minimum, maximum, and average latency for the packets are displayed. Sometimes 4 pings isn't enough to troubleshoot intermittent connectivity issues. To persistently ping a host, I'll type ping-t and its IP address, 192.168.51.1. It will continuously ping, showing latency and possible packet loss. To end the stream, I'll type Control-C. The CLI will spit out complete statistics on all of the pings sent. Say I wanted to ping a host a number of times between 4 and infinity. Ping-n allows me to specify a total number of pings to be sent, be it 5, 50, or 100. 192.168.51.1. To ping an IP and resolve it to a DNS name, I can type ping-a and the host to resolve, gregsowell.com. The CLI will attempt to resolve the address and continue on pinging the host. I can also adjust the size of the packets being sent by typing ping-l and the number I'd like it to be. In this case, I'll say 1500.51.1. This can be especially useful when troubleshooting maximum transmission unit issues. The next go-to tool is traceroute. In Windows, the utility is called tracert. Traceroute uses ICMP packets to map out the path to a destination host. For my first trace, I can type in tracert gregsowell.com, which is resolved through DNS to 104.21.16.186. As it hops through, I may occasionally see an asterisk. This means a packet was lost. If a hop responds with all asterisks, this likely means it is blocking ICMP. It could also mean that the device is having severe issues. On the left, I see the hop count go up as the packets head towards the destination. The amount of latency, IP address, and DNS name of each hop is also listed. Once the destination has been reached, the CLI prints a trace complete message, or it will count up to the default of 30 hops and say complete. A hop with erratic latency might be indicative of an issue. I'll now add the -d flag. tracert-d gregsowell.com. This tells traceroute to skip resolving the names of each hop. This can speed up the trace since the client isn't waiting to resolve addresses. I'll stop the process with Ctrl-C. The -h option lets me change the default max number of hops. The last tool is pathping. Pathping, and then the IP address in question, 192.168.88.1. This marries the attributes of both ping and traceroute. It will do a traceroute, then ping each hop for 25 seconds. This attempts to give better statistics than either a traceroute or ping alone. It provides the round-trip time as well as the packet loss along the way. It has many of the tracert options like -h for max number of hops and -n to not resolve DNS names. I can also specify -q to adjust the number of times it pings each hops. I can specify -q to adjust the number of times it pings each hop. The default is 100. All of these tools, used in combination, especially ping and traceroute, are essential to troubleshooting network connectivity issues. The ARP command is a tremendous troubleshooting tool for ARP issues, as well as Layer 2 troubleshooting. ARP stands for Address Resolution Protocol and is responsible for doing the Layer 3 IP mapping to Layer 2 MAC addressing. To view the ARP cache, I issue the arp-a command. Say, for example, I have a rogue DHCP server on the network. It's handed me an IP and default gateway that's a false path to the internet. I can do an ipconfig /all and take note of the DHCP server that handed me the IP. Next, I'll ping the IP of the server. Ping 192.168.51.1. This will force my machine to do an ARP request to the rogue server. I can now issue the arp-a command to determine what the MAC address associated with that device is. Then, I could track down the MAC address of this client in my switches and shut it down. The ARP cache breaks down the IP to MAC mappings per interface. It will list them as either static, which are user or system created, or dynamic if they are learned from a neighbor. If I have a specific IP address I'm looking for, I can issue the arp-a and its IP address, 192.168.51.1. If I have a cached entry that I want to remove, I can issue an arp-d and the IP address, 51.1. Though not frequently necessary, the arp-s command will allow me to add a static IP to MAC address entry. The arp command isn't used very frequently, but when it's necessary, It's indispensable. A very useful tool with unexpected uses is Telnet. By default, it isn't installed on Windows anymore, but a simple Google can give you the steps to install. On my Windows 10 machine, I can enter the following command to install it. Now, from a command prompt, I can simply type Telnet to enter the program. While the Telnet utility allows me to telnet into equipment for remote administrative purposes, it's also extremely useful for troubleshooting. I looked up google.com's MX record, then traced down the A record associated with that entry. I'm going to test SMTP on that mail server by telnetting into it. From the command line, I'll simply enter telnet, then the IP address to connect to, and last the port to connect on. In this case, telnet 142.250.138.26 space 25. By default, Telnet wants to connect on port 23, but in this case, I'll change it to port 25. I have the prompt available from the mail server. I can give the server an LO command and see if it responds. This is great for testing simple connectivity to a mail server or relay server. I can also verify a web server using Telnet. I'm going to telnet to gregsoul.com on port 80, the standard HTTP port. Telnet gregsoul.com on port 80. If the session shows a blinking cursor in the top left, that means I have an established TCP session. From here, I can type any letter and hit enter. The server spits some info back at me with an error message. Sometimes the server won't spit anything back, but I can still see if the session is established. Telnet is a quick and simple way to verify if a TCP session can be established. Netstat is a great program for diagnosing port and session issues. On older machines, I can simply run it from a standard command line, but on newer versions of Windows, I need administrator privileges. I'll click on the Start button and type CMD. I'll then right-click on Command Prompt and choose Run as Administrator. Just typing Netstat will begin to slowly give me information on active connections. To stop the program, hit Ctrl-C. I never run Netstat by itself. I always add some additional parameters. Running Netstat-A will also display listening ports. That was a lot of information fast. If I want to slow it down to a single page of output at a time, I can add pipe more modifier to Netstat-A pipe more. The enter key will move the results down a single line at a time, while a spacebar moves it down a whole page at a time. Moving from left to right, it shows the protocol in use, the local IP in the connection, then a colon, and the local port in use. Then I see the remote host and remote ports, and finally the state of the connection. This is especially useful if I'm troubleshooting a port conflict. So, for example, I'm trying to run a web server on port 80. But that port is already in use. Netstat-A only shows me listening ports, but not what has it locked open. If I add -B, then it will also indicate the application using the port. So the command will be netstat-AB. As you can see, it lists the various applications in brackets. Say now that there are multiple instances of an application, but only one of them has the port locked. How do I identify the one offending app? I do this by adding the -O flag, which will show the process ID of the program too. So I type in netstat-abo. I can then note the process ID and reference that in Task Manager to kill the program. The next flag I use most often is -N, which tells Netstat to skip DNS resolution on all of the IPs. I combine all of this together on 99% of my Netstat queries. This equates to netstat-abno. I remember all four letters by thinking of it as ab? No. Do I have abs? Absolutely not. Netstat also allows me to look at the local routing table on the machine by typing netstat-r. I can get the exact same information by typing route print. This gives me the IPv4 and v6 routes along with their gateways. Netstat-s pipe more gives a lot of good statistical information. It will tell me about some of the v4 information like packets received, errors in those packets, fragmented packets, and so on. It will then give me the same information for IPv6. It next lists TCP, UDP, and ICMP statistical information. To supplement the -s information, I can add a -p and then specify a specific protocol I'm interested in, like TCP, UDP, or ICMP. This will allow me to keep rerunning the command to watch those counters increment. So now, my command is netstat-sp ICMP. If I want the command to keep refreshing, I can add an interval number in seconds at the end. I'm going to view ICMP statistics every second by entering netstat-sp space ICMP space 1. While this is running, I can open another command prompt and start a ping so that I can see the counters increment. Again, this is one of those utilities that aren't used too frequently, but this is the only built-in application that shows port status on a machine.